the auxiliary equation look like? Of course, that factors as.
M plus 3 squared.
So you get m equals
3 and 3. Or negative 3.
damn. We know that how many solutions exist? Two. And how many does this lead to so far? One. So the one solution we got, y1, is what? I like it. That's what we got. Does anyone know what to do if we only have one solution? We have a whole freaking section that did that to us, right? Yeah. Now, we're going to develop a process so we don't have to do what we're about to do every damn time. But I want to do it once so you see where things come from. This is going to be true. Just because I picked this to be m plus 3, doesn't it make sense that whatever I put here, what we're about to do should always happen just about the same way? This is just a number. Who gives a shit? This is going to be m plus a squared. So whatever I'm about to do is basically going to always happen in this case where I get one real root, a repeated root, right? Do you guys understand that? Thank God. So we're going to do this once, and then we can just realize that the same thing that happened should happen every single time in this case. Okay. What are we going to do? I know a solution. What can I do now? I know one solution. I want to get the other solution. I know there's a second solution.
Y.
Yes, so y equals u e negative 3x.
First derivative.
So I'll just charge through this gather. Got this right. So then I get y double prime equals u double prime e negative 3x minus 6 u prime e negative 3x minus 9u e to the negative 3x, Jeff. There you go. There you go, Jeff.
Or the y prime.
Oh, yeah, thank you. For some reason, I just have trouble. Okay, cool. It's always good to have a room full of people watch you do work.
So they're questioning my paper.
No, don't question yourself ever about that. Say, wait a minute, Jeff. I go, oh, yeah. All right. So again, please, dear God, realize this method sucks. That's why there's a shortcut that has been invented that I'll eventually go over. Maybe not tonight yet. And we're only going to have to do this once, though, for this case, like I said. So we can suffer through that. So what do we get when we replace everything? We get u double prime e. So I'm now going to replace all these into my problem. E negative 3x minus 6u prime e negative 3x minus 9u e negative 3x. Then I get a plus 6y prime, so I get plus 6u prime minus 18. Is that cool so far? You guys see what's happening?
Shouldn't that be plus 9u? Yeah. So you got negative 9u?
Oh yeah, because the negative 3 came down, but I had it written as a 3. Thank you. So that'd be plus 18. I like it. Cool. It's always a group effort. So then plus, finally, 9u. Now, not to take any of your steam away, so I appreciate that, but how would I have been able to determine on my own right now that I made a mistake with that? The terms with just a u wouldn't have gone away. So when you're doing this method, this reduction of order method, that has to happen if you're doing it correctly. That's the whole idea of it. So let's see what we get. We u double prime e negative 3x. This goes away. Just because that happens sometimes. We saw it happen last time, right? And these will definitely have to go away, and they do. Do they?
Negative 9.
Yeah, that's right. Because I was off by, I think. So those go away. I like it. So we get, like we did last time, something that's just related to the second derivative. I love this. And does e to the negative 3x, is that ever equal to 0? So let's see, this came from
Putting y into
plus 9 ue to the negative 3x. Did I mess up on my sign somewhere? Probably, Jeff. You're trying to do this so quick. Let's see. Negative 3u, negative 3x. Negative 3u, negative 3u. And then that would have been plus 9u e to the negative 3x. Let's see. Oh, well, yeah.
Sorry, I don't see how we get the plus 18. I'm still getting them.
Oh, so that's from 6y prime. So it should be, yeah, that should be minus 18. Oh, I love that.
Yeah, the top.
I love that. And that, of course, this one should be plus. Okay,
And the last one's up to plus as well.
okay. Sure, I love it. Whatever makes them going. So yeah, you gotta love when there's e to the negative and you keep changing the signs every time you take a derivative. Hopefully you go a little slower than I did, but I appreciate the help. That has to happen, so it's kind of nice that the problem gives you an idea of where you made a mistake. So I can go back and analyze my signs for these and see where a mistake was made, because I know a mistake was made. It's really nice to know when you made a mistake. It's even nicer to not make it, but so here, since this is never 0, I'm gonna freaking yeah. So what's u prime? Yeah. Constant. And then what's u? Cx plus c1, we'll say, right? Is that cool? You can do like the book and name, as they come, you can name them 1, 2, 3, 4. As long as you differentiate and change them as things happen to them, that's the new thing we're not used to. And then that, of course, I can use, I'll get y equals u times e to the negative 3x. That's what started this whole sucker off. We had an answer, we did this, we did all this crap just to figure out what u was. And now, what's the thing I picked up? Yes, so what's it seem? Whenever there's a repeated root, it seems like I get e to that, like I normally would expect, but then I get x e to that. That's the adjustment for when there's a repeated root, because no matter what that number would have been, everything would have happened the same way except with that number there. So let me give you this. There's this third case we haven't done yet. Let me give you this handout here.
So there'll never be a case where they don't cross out for the last u.
For this method, if it's the correct type of DE to do this method for, that is guaranteed to happen. It has to. All right, so I borrowed from this a little bit. So remember that one we did with the 7 and 12? We could factor that? Without, that's up here for reduction of order, so you can see what that looked like from section 4.2. But now we know how to do those type. Remember, reduction of order works for more than this method does. This method requires the coefficients to be constants. In fact, it's in the title of the section. Yeah?
Right there, on the last problem, when you factored in the e to the negative 3x, did it just become, the second part just became the other solution you already found?
Yeah, exactly. This actually ends up being the total solution, to be honest. It's just that the online homework, for some reason, was being a real picky and saying, I only want the new part. When you do this process, you actually get the old and the new together, right? Hold on. Good.
Your A, B, and C must be constants.
That's right. Constant coefficients. So we went over case 1 down here and case 2. Case 3, of course, must be the only one we have left, which is when there's complex conjugate solutions. And it's kind of nice that I didn't quite get there because I want time to review something very fundamental. Good old e to the I theta, right? You guys remember Euler's identity for one thing, but also the rule, you know? All right, we'll go back over that again. It's got, everybody's taken 280. So you guys have done like e to the x Taylor series, Taylor polynomials, and sine theta, cosine theta, oh shit. Right, so we're going to sort of do a quick little proof of a relationship that's required to put the answer in a nice form for when there's complex conjugate solutions. That's with me. So this method is all based on factoring a quadratic. That's what this method is based on. That's why it makes sense. There's going to be 3 cases, because there are 3 cases for what comes out when you factor a quadratic. I like it. That's perfect. So any questions about the immense amount of stuff we've gone over? All right. Oh, I don't think I said this yet. Did I? I said Monday there's a quiz, right?
No.
Oh, good. All right. So Monday there's a quiz. So on Monday the quiz is on 4.1 and 4.2. I'm sorry. Let's make it this. This is what I mean. Let's make it Wednesday. 4.1, 4.2. And then the Monday after that we'll have a quiz on 4.3 and 4.4. Yeah, like, so a week from today will be the next quiz, and then that Monday after that will be the next quiz after that. Yeah. Quiz after quiz after quiz. You want more grades, trust me. All right, I think that's plenty. I'll see you guys next week.
For 4.2.